Hello everyone. In this video tutorial, we will see how we can create a chatbot to chat with books or with our own PDF files. In this project, I will be using LangChain, Llama 2 model, and Pinecone as our vector store. And we will store our embeddings in the cloud using Pinecone. We can also store our embeddings locally. For this, we can use Spice Vector Store provided by Facebook. But in this project, I will be using Pinecone because it has certain advantages. First of all, Pinecone is an external vector store that LangChain support. The other advantage is that using Pinecone, we can make the Pinecone database available for other people to query as well. So here you can see the architecture diagram of this complete project, which we are implementing in this tutorial, which is chatbot to chat with books or with our own PDF files. So we will be designing a chatbot so that we can chat with books or with our own PDF files, or you can say that we can do a question answer with our books. So we can ask questions using our chatbot with our books, and we will get the response back. Or we can also ask questions from our PDF files as well, and we'll get the response back. So here is the complete architecture diagram. So let me explain you the complete process flow. So first of all, either the user will upload a PDF file or a book. Then in the next step, what we will do is we will extract the data or content from that PDF file. So here in the step number 2, we will be extracting the data from that PDF file. So here the user can upload multiple PDF files as well, or they can also upload multiple books as well. So the user can upload a PDF file or a book. And then in the next step, using PyPDF Python package, we will extract the data or content from that PDF file, and we'll save that data, extracted data in a variable. Okay. So now we have extracted the data from the PDF file. So now we cannot pass this data directly to the large language model, because large language model has an input limit. Like large language model has an input limit, like we can pass, for example, maximum number, for example, 10,000 characters in the input. So we can pass 10,000 English characters at the input of the large language model. Mostly large language model have this input, like you can pass around 10,000 characters, English characters at the input of the large language model. So, but when we extract the data from the PDF or from the book especially, you can see that we have much more than 10,000 characters. Like we have around 80 to 90,000 characters in a book, or 40 to 50,000 characters generally in a PDF file. So as we have input token limit, or you can say the input character limit at the input of the large language model, like at the input of the large language model, we have some input limit, like we can pass maximum 10,000 characters at the input of the large language model. So now we have extracted the data from the book PDF, and it is much more than 10,000 characters. So we divide the data into chunks. So we create small number of chunks. Okay, so the next step, we will divide this text data, extracted data, into small chunks. So we can create multiple different chunks, like n number of chunks, and each chunk will have around 2,000 characters. So we will define the chunk size. So each chunk will have 2,000 English characters. After dividing the complete data into small number of chunks, we will create embeddings for each of the text chunk. So embeddings are basically vectors, or you can say floating numbers. Okay, so they are used to compress the size of the text chunk. So embeddings are basically vectors or floating point numbers. So this is like we have embeddings. So embeddings are usually like this: 0.1, 0.2, 0.3. So this is the form of embeddings we usually have. So embeddings are basically floating point numbers, or these are vectors. Okay. So after creating embeddings for each of the text chunk, like we have multiple text chunks, so we create embeddings for each of the text chunk. So after creating embeddings for each of our text chunk, then we will create a knowledge base using these embeddings, or you can say that this is our vector store. So where we were using these embeddings, I will first build a semantic index, and then I will build a knowledge base. So you can say knowledge base is a vector store. Okay, so here we are using knowledge base or vector store. Okay, So here we are using Pinecone over in this tutorial I told you at the start. So we will be using Pinecone as our vector store. Okay. So what is the knowledge base, or you can say vector store? In the knowledge base, all of our embeddings are saved. Okay. So we have extracted the data, we have split the data into text chunk, and then we have created embeddings for each of the text chunk. And then we have saved the embeddings in the knowledge base. So knowledge base, you can say that it is a vector store, and here we are using Pinecone vector store. So in the vector store, our embeddings are saved. So you can say that here we will have these types of embeddings. So now you can see that our embeddings will be the like this form 0.1, 0.2, 0.3. Okay. So like in this way, our embeddings will be like this. So in this way, we have huge amount of vectors knowledge base over here, or you can say that we have a vector store. And in this project, we are using Pinecone where our embeddings are saved. So using Pinecone vector store, we are saving our embeddings. Okay. So when I user, for example, I ask a question. So for example, when a user asks a question, we create embeddings for this question. So now user has asked a question. Now I will create embeddings for the user question. Okay. So now, for example, these are the embeddings for the user question. So now we have the embeddings saved in the knowledge base. Okay. So now these are the embeddings from the user question. Now in the next step, I will be doing semantic search. So I will be just comparing these embeddings with the embeddings saved in the knowledge base, and I will just find a relevant answer to this question. So I will just find a relevant answer for this question in the knowledge base. So after finding the answer, we will rank first top 5 results. So by default, K value is 5. So we will rank the top 5 result over here. So after ranking the top 5 result, we will pass these results. Like for the question, for each of the question, we will rank top 5 results. You can rank 3 result, 2 result, 1 result. It depends on you. But by default, K is equal to 5. So we rank top 5 results, which we get from the knowledge base of the question that the user has asked. So then we rank the results we get from the knowledge base. Then we pass all those results to the Llama 2 model. And then we also pass the question that user has asked to the Llama 2 model directly as well. And then what response we get, we show that response into our application. Okay. So this is the whole, how the complete architecture of how this complete process flow works. So just a short overview. First of all, user will upload a PDF file or a book. Then we extract the data from that PDF file. Then we split that data into text chunks. Then we create embeddings for each of the text chunk. So after creating embeddings, these embeddings are basically floating point number. Then we create a knowledge base or a vector store where we basically store those embeddings. So when the user asks a question, we create embeddings for this question. Then we do a semantic result. We try to find an answer for the question using the vector store which we have created. So if we have asked a question and the answer is available in the PDF, so it will search for the answer from the knowledge base in which we have saved our embeddings. So it will get the top 5 answers for the question we have asked for, and then we will pass those answers to the Llama 2 model, and Llama 2 model will get the question directly as well, and then it will generate a natural response to the user. So Llama 2 model will then generate a natural response that we get in the end. So this is the complete architecture diagram, and in this tutorial I will be using the Field Guide to Data Science as the book, and I will be using YOLO 7 V7 paper as the PDF file. So let me show you paper as well. So we are using this PDF file, and I have already shown you the book which we are using. So this is the YOLO V7 Object Detection Officer Research paper. So we will be using this as a PDF file. We will upload this PDF file, and I will ask some questions from this PDF file. Okay, and we will be using this book as well. I told you the Field Guide of Data Science. We will extract the data from it, and then I will ask question from this book as well. So let's get started. So here we have the complete Google Colab notebook. So in this project, I will be using Llama 2, Pinecone plus LangChain. So Llama 2 is the latest large language model released by Meta AI. So if you just go to over here, so let me just give you a short intro about Llama 2 model as well. So the original version of Llama was available only for research use, but Llama 2 is available for research as well as commercial use. Llama 2 comes with pre-trained as well as fine-tuned models as well. Llama 2 includes 3 different models. You can see that here is the 3 different models, one with 7 billion parameters, the other with 13 billion parameters, and other with 70 billion parameters. And here we have the pre-trained model. So the pre-trained models can complete the prompt, but for our chatbots or for question answer uses cases, we use fine-tuned model. So we will be using fine-tuned model in this case because the pre-trained model, we will not be using the pre-trained model in this specific use case. The reason is that the pre-trained model can be used to complete the prompt. So let me just show you about it as well. So Llama GitHub. So let me just show you. If I just go below down, so you can see that these models are not fine-tuned for chat or question answer. So here I am doing question answer from book or PDF. So these pre-trained models are not fine-tuned for chat or question answer. They should be prompted so that the expected answer is the natural continuous one of the plot. So it can be used for sentence completion. Pre-trained models can be used for sentence completion, but they cannot be used for chat or for question answer. So the fine-tuned models were trained for dialogue completion. So we will be using fine-tuned models in this project because they are trained for question answer or dialogue completion as well. Okay. So this is a short intro. And here you can see that Llama 2 outperforms many other open source models, which you can see over here. So here you can see that Llama 2 outperforms many other benchmark models, which include MPD, Falcon, and so these are all the large language models. And here we have the MPD with 30 billion parameters, Falcon with 40 billion parameters. And here we have different benchmark dataset you can see over here. So on this benchmark dataset, you can see that Llama 2 with 7 billion parameters outperforms this Falcon and MPD. Like here we are getting the accuracy score 45.3, but here we have 26.2 and 26.8. While here you can see that Llama 2 with 70 billion parameters, we are getting 68.9 accuracy ratio, and with Falcon 40B, we are getting 50.5, 55.4. So Llama 2 model with outperforms many other open source as well as closed source model like OpenAI model in many use cases as well. And here you can see on this benchmark dataset, the performance comparison is also provided over here as well. So let's move towards the code part and let's start. I will now start explaining the code as well. So first of all, I will just install all these required packages. So before running the script, let me just go over here and select the runtime as GPU. So that's fine. So now I will just install all these packages. So the package installation will take a few seconds. So let's see how does it goes. You can see that the packages are installed. So that's been done. So let's move towards the next step. So now I will import all the required libraries. So here you can see that I'm importing PyPDF loader, online PDF loader. So online PDF loader help us to read the text from an online file and just extract the data from that PDF file. And using PyPDF loader, we can just upload a PDF file from over in our local system into this Google Colab notebook. We will extract the data from that PDF file. And then we have recursive text splitter so that we can split the text into chunks. And then we have Hugging Face embedding. So we can create embeddings for each of the text chunk. And then we are using Pinecone as a vector store. And for Hugging Face embeddings, I'm using sentence transformers embeddings in this tutorial. So I've just imported sentence transformer. And then we have load QA chain so that we can load our query as well as the relevant answer from the vector store, and then we can do a question answer as well. And here we are just importing Pinecone and OS to set up the environment. So let me just upload a PDF file. You can also basically, if this is the field guide to data science book that I showed you. So if you just want to extract data from this book, you can also do this. And if you want to just load the PDF file, you can also upload it. So I will just upload the PDF file from my local directory over here. I think this is the wrong one. I just show you this one. So this is the PDF file. So I'm just loading the PDF file. You can also extract the data from the book by just uncommenting this. And if you just comment this, so you will be able to extract the data from the field guide to data science book, which I showed you. So this is the book. So if you just uncomment this line, above line, which I showed you, so you will be able to extract the data from that book. So here, just click over here and copy path from here. And just, so now we are just loading our PDF file, and now we'll just read the text inside this PDF file which we have. So if I just write data over here, so you can see that this is all the content which we have in this PDF file, and we are able to extract that content from the PDF file. So you can see over here, we are able to extract all the data which we have in our PDF file. So that's look good. So if I just show you, so now you can see over here, we have done this part. We have extracted the data from our PDF file. So now you can see that we have extracted the data from our PDF file. So now we will split the text into chunks. So we have set the chunk size 500, and we will just split the complete extracted data. So this is the complete extracted data. We will split this data into small chunks. Okay. So now you can see over here, we have 152 different text chunks created, and each chunk has 500 English characters. So each chunk has 500 English characters. So let me just show you one chunk. So you can see that this is one chunk and it has 500 English characters. So now 500 is the maximum limit. It can have around 450 to 460, but 500 English characters is the maximum limit. So now we are just setting up the environment. Here I'm just passing Hugging Face API token, and here I'm just passing Pinecone API key and Pinecone API environment. So let me just show you how you can get this. Here you can see Pinecone. So if I've just created an account over here, it's free. So you can simply create an account. So this is my environment, and this is my API key. Okay. So first of all, we just need to create an index for this project, and we are using LangChain Pinecone, and our dimensions will be 384 for this project. Okay, I will later show you why we are choosing this number 384, and this index name will be LangChain Pinecone, and I will now create an index over here. Okay, so now you can see that I'm just using free account, so you can see that dimension 384, and here I've just created an environment, and here are our API keys. So these are the things we needed, and we just need to create an account on Hugging Face as well. And here you can see that in the access tokens, you will find your API key as well. Okay. So let us go back to the code. So here you can see that I've just added my Pinecone API key and Pinecone environment. So let me again tell you where you can find the Pinecone environment. So this is your Pinecone environment. You can just copy this and just paste this over here as well. Okay. So here you can see that Pinecone environment, and here is my Pinecone API key as well. So let's run this. So now in this tutorial, I will be using Hugging Face embeddings. I will be using sentence transfer embeddings available on Hugging Face. So if you just want to see it, let me just show you. So these are the transformer embeddings available on Hugging Face. So you can easily use them. So just copy this from here, and you can use this sentence transfer embeddings in your project. Okay. So now here I'm just initializing the Pinecone, and here you can see that I'm just passing my API key. So instead of passing this API key over here, you can just add this like this over here, and here you can add the Pinecone API environment. Okay. So plus you can see that here we have created index name as LangChain Pinecone. So if I just show you, so if I just go to the indexing, so you can see it's still initializing. So if I just run the cell, it will give error because currently it's initializing. And here we have the index name as LangChain Pinecone. So I will just write this index name. So we will just wait for it that it get initialized so that we can just save our that embeddings into this knowledge base. This is vector store. So you can see that it's ready now. So here you can see I've added the index name. Okay, so let's run this. So now, now you can see that we have divided our text into text chunks. You can see that. So we are done with this part till now. So now we are done with this. We have split the text into chunks. Now we'll create embeddings for each of the text chunks. Okay. So if I just go over here, I have downloaded all the embeddings. Okay, so all the embeddings are being downloaded, and here I've initialized the Pinecone as well. So here I'm just passing the downloaded embeddings, and here you can see that I've just passing all the text chunks which is saved in the docs variable. So all the text chunk is being passed over here. Okay, so we will create embeddings for each of the text chunk, and we will save that embeddings in our Pinecone vector store. Okay, so let me show you. So now we are just creating embeddings for each of the text chunks, and we are just saving the embeddings into our knowledge base or vector store, which is Pinecone is our vector store. So you can see that we have around 152 different text chunks. So we will have 152 vectors store as well. So let me see what is the error. So let me just run this again. Okay, so let me just run this and let's see. Okay, sometimes it's gets initialized a bit late, so that was error appear. So you can see that here we have 152 different text chunks. Okay, so let me just show you over here. So currently, if you just click over here now, so you can see that we have 152 different chunks, and we have 152 different vectors. So for each text chunk, we have one vector. So you can see that we have 152 different vectors, and we have saved our embeddings into our knowledge base or Pinecone vector store. So we have saved these embeddings. Okay. So now you can see that we have saved embeddings, but if you already have an index or if you have already saved the embeddings and you want to use these embeddings into some other project, then you can run this cell and then you will skip this step. So if you have already saved the embeddings and you want to use these embeddings in some other project, then you will just run this cell. So now I will do the similarity search. Okay. So now here I'm just doing the similarity search. So I'm just this is a user asking a question. Now we'll create embeddings for this. So now what I'm doing is, let me just show you. So here you can see that I'm a user. I'm asking a question. Now I'm creating embeddings for this question. And then we are doing semantic search or similarity search from the knowledge base. Okay. So you can see over here, I'm just asking a question. And now I'm just creating embeddings for this question. And here we are just getting the answer. So it is returning currently top 3 answers. So if I just set the key value is equal to 1, okay. So you can see that I'm just getting 1 answer, but by default, we get 3 answers if you just don't set the key value 1, okay. So you can see that YOLO V7 outperforms. So here we have the answer. If for the result, if we compare with YOLO V4, it has 75% less parameter, 36% less computation. So this is the first answer. If we compare YOLO 7 with YOLO R using the input resolution 280, the inference speed of YOLO V7 is 8 FPS faster than that of YOLO R P6. So, and this is the third answer we have. So now you can see that we have 3 different answers for this question. So if I just show you the architecture now, So you can see that we have created embeddings for the question, and then we are doing semantic search or similarity search. And now we have three different answers. So we have three different answers. So now I will just pass this answer to the Llama 2 models, and we'll pass the question to the Llama 2 model directly as well. And Llama 2 model will generate a natural response. Okay. So now here I'm just initializing the Llama 2 model over here. So I will be using like Llama CPP library to run the Llama 2 model. We will use the quantized model, but we can also quantize the model using the Llama CPP library as well. So why? But it is always better to use pre-quantized model. Okay, so Hugging Face community provides Llama 2 quantized models. So why we are using quantized model? Because we can easily run the quantized model on free Google Colab GPU as well as on our local system. Plus quantization optimizes the resources usage by decreasing the precision. So we cannot run original Llama 2 model on free Google Colab. So we use the quantized model, okay, which optimizes the resource usage by reducing the precision. Okay, so you can see over here, the Hugging Face community provides quantized model, which allows us to efficiently utilize the model on T4 GPU. So, okay, there are several variations available, but one that interests us is GGLM mod library. So we are using Llama 2 13 billion parameters chat model with a GGML quantized model. Okay, so quantization reduces precision to optimize resource usage. So quantization is a technique to reduce the computation and memory costs of running inference by representing the weights and activation with low precision. So here we are using a Llama 2 13 billion parameter quantized model so that we can run it easily on our free Colab, because we cannot run the original model on our free Colab, but we can run this model on our free Colab because free Colab version comes with 15 GB memory card. You can see over here. Okay, so we have installed the required packages. So now I will just import all the required libraries over here. So now here you can see that I'm just using this quantized model. You can check the model by clicking this layer here. And we are using the Q5 quantized version. So now I'm just downloading this model from Hugging Face. Now you can see that I'm just downloading this model from Hugging Face. So this model is around 9.76 GB in size. So this might take few seconds before it is ready. Now you can see that we have downloaded the model. So now I'm just loading the model, and here I'm just setting the context size as 1024. So 1024 English characters are allowed at the input, and we have set the maximum tokens at 156. Okay, so let's load the model. So this will take around 1 to 2 minutes to load the model. Now can see that we have loaded the model. So now I will load the QA chain, and I will just ask first question from this PDF, and YOLO V7 outperform which models? So this is the first question which I am asking. So now it's doing a similarity search, and now it will just give me the answer. So you can see that here I'm just loading the document, and here we have the. So now here basically create embeddings for this query which I have loaded, and then it does the similarity search from our vector store, and you can see over here. So meanwhile, before we get the answer, so now what it's doing is here, I have loaded the question. It's creating embeddings for this question. Then it's do the semantic search basically from our knowledge base. So if I just tell you over here in this doc search variable, our knowledge is this entire vector store is saved. So if I just show you above, so you can see that in this doc search variable, our entire knowledge base is saved, or our vector store, or our entire PDF embeddings are saved in this doc search variable. So in this doc search variable, our entire PDF embeddings are saved. Okay. So now what we do is when the user asks a question, we create embeddings for this question, and then we will do the similarity search. Okay. So after doing the similarity search, we get the 5 answers from here, and then we just pass those answers over here as well as the user query and to our Llama 2 model. And here you can see that YOLO V7 outperforms WinL on next Excel in terms of both speed and accuracy. YOLO V7 outperforms. So you can see that we get the answer. So if I just show you docs, okay. So you can see that these are the 3 answers we get from our which we get over here. So these are the 3 answers which we have ranked over here. Okay. And now we are just passing this answer to our Llama 2 models, and Llama 2 model is generating a natural response. Okay. So if I just ask another question, YOLO V7 trained on which data set, and let's see what answer we get. So MS Coco dataset, this is the perfect answer. So now if you just want to ask question from a book as well, so we can also do that as well. Let's see how we can do this for a book. So comment this out. So now I'm just downloading the, okay, so check the URL return status. Okay. So I think there's an issue with the URL. Okay. Okay. So I was getting the error. So I've just pasted that book into my drive. And here I'm just downloading that book from the drive. And here I've just pasted the path of the book. And you can see that this works fine now. Okay. So now we have loaded the book. So now we will split the text into chunks again, which we did for the PDF. So here we will have many chunks. So here you can see that we have 383 chunks. So that's a huge number. Okay. So what we will do is, now again following the same steps. So we can just skip the embeddings. We have already downloaded the embeddings and we have already initialized the Pinecone. You can just want, and now we will create a vector store for these. So previously we have 152 text chunks. So now previously for the previous PDF, we have 152 text chunks. Now here we have 383. So it should be now, let me just close this up and let me just navigate to other screen. Well, so now you can see that we have 535 vectors in total. So 382 plus 152. So this is 153, 83 plus 152. So this is 535. So this is correct. Okay, so let's go further ahead. And okay, so we have stored our embeddings in our vector store in Pinecone. Okay, so now we will you can ask a question over here. Here, I'm just asking a question. What are examples of good data science team? So you can see that here we are just getting top 3 ranked results. So now I'm just passing this to my Llama model, which I did back. So the same approach which I'm following over here. So here the Llama model, and here we just pass this. Okay. What are the examples of good data science team? And this will be passed to my Llama model. So these results will pass to my Llama 2 model, and it will generate a natural response. Good data science includes one that can address problems with high return from key stakeholders, work collaboratively across business units. Okay, so you can see that across business units and have a have a cross-cutting view of organization. So here we have the answer. So here we can ask another question. What is the next stage of data maturity? So in the correct stage of data majority, an organization requires and prepares data for use in data science activities. So this stage involves creating a data lake. So here we are getting a quite detailed response now. Okay, so you can see a quite detailed response is being provided over here. So you can see here we have a quite detailed response into like stage of data majority and organization requires and prepare for use in data science activities. So you can also use other open source model like 95XXL, and you can just ask question and generate the response as well. Okay. So that's all from this tutorial. I hope you have learned something. See you all in the next video. Till then, bye-bye.